Hi all. In hydrology, the most important part is about the precipitation, how to measure the precipitation or the rainfall. So we will discuss in today's session what are the different types of the precipitation, what are the different forms of the precipitation, what is the difference between precipitation and rainfall, and how can we measure the rainfall by using different rain gauges. So all these things we will discuss in today's session. So we'll start with the forms of the precipitation. So there are the different forms of the precipitation. Before that, I would like to discuss with you what is the difference between precipitation and rainfall. Because many a times we use the term precipitation, sometimes we use the term rainfall, but actually there is a difference between precipitation and rainfall. Precipitation includes all forms of the water, so whether it is gaseous form, whether it is a liquid form. In rainfall we can say it is just a liquid form. Okay, so in general it is in the liquid form, so we can use the rainfall or we can use the precipitation. But when we focus on the precipitation, so there are the different types of the forms of the precipitation. So the first form of the precipitation is drizzle. So what is meant by drizzle? So it is also based on the droplet size, water droplet size, and what kind of intensity it has. So when water drop is less than 0.5 mm in diameter and which has the intensity less than 1 mm per hour, then we can say that this is a drizzle. In case of rain, as I told you that it is in the liquid form, but water drop size is around 0.5 mm and above. In case of hail, it is balls or lumps of ice with a size of 0.5 to 0.5 centimeter. Snows are ice crystals or thin flakes of ice, whereas sleets is a mixture of ice and rain. There is one more kind of or form of precipitation which is called as fog. So fog is basically a low level cloud which touches to the ground. So this is all about the forms of the precipitation. So forms of the precipitation and types of the precipitation are different. So what we have discussed is all about the forms of the precipitation. Now we'll discuss what are those factors which affects on the precipitation. So there are the different factors which affects on the precipitation. The first factor is height of the station. Height of the station, or we can say the altitude. So, as temperature decreases with altitude, thus moisture holding capacity of air decreases and less moisture is available for the precipitation. So, in short, we can say height of station increases, then precipitation decreases. So, height of station is inversely proportional to the precipitation. Second factor is presence of mountains and their relative position. So, if mountain ridges are across the direction of flow of wind, then lifting of air occur. As the air containing moisture lifted up, the temperature reduces and causes precipitation on windward side. This is also called as orographic precipitation, and obviously at leeward side there would be the less precipitation. It also has a connection with the types of precipitation which we will discuss in the next slide in detail, which has a connection with the orographic precipitation. The next factor is nearness of the oceans and seas. Place near the ocean will have a higher relative humidity because of continuous supply of water vapor, and it leads to higher precipitation. The next factor is forestation and urbanization. In the forest area, transpiration is more and the temperature is less. Thus, due to the forestation, precipitation trend basically precipitation increases. The last factor is wind direction. How wind affects on the precipitation. So areas which receive wind from warm ocean gets higher precipitation, whereas areas having cold wind receive less precipitation. So in this way, basically wind direction or the wind affects on the precipitation. The next is types of the precipitation. So there are the different types of the precipitation. The first type is cyclonic precipitation. So what is meant by cyclonic precipitation is basically, in case of cyclonic precipitation, because of the thermal variation, low pressure belts are developed. Air from surrounding area flows towards low pressure belts and changes into whirling mass because of rotary motion of the earth. The movement of whirling air results in cyclone formation, which has a different feature. Like we can say the first feature is it is also known as hurricane or the typhoon and or tornado occurring to whirling speed. It covers around 10 kilometers square to 1500 kilometers square area and moves with velocity of 100 kilometer per hour or even more. So you can imagine how vast and large it is. Air gets lifted from central portion of cyclone and expands, causes cooling of air and then condense, resulting into the precipitation. So in this way basically precipitation occurs. Whereas in case of convective precipitation, when there is a hot day, so ground surface and air near ground gets heated, so it rises into atmosphere, cools and condense, which results into the precipitation. So in this form the convective precipitation occur. And the last type is orographic precipitation, when winds has a sufficient water vapor are obstructed of a range of hills or mountains. Actually we can see this particular orographic precipitation with the help of figure. I have just drawn the rough figure. So here actually you can see this is the ocean, this is the windward side, this one is the leeward side. When actually this uh, because of the sun heat, this air will get lifted up which has a moisture. Okay, so air gets cooled and condensation takes place and results into the heavy precipitation on leeward sides. So when it achieves the certain height, okay, because of the decrease in temperature, that air becomes cool and get condensed and occur precipitation here at leeward side only. So this is heavy precipitation which occurs at leeward side. So obviously there will be the less precipitation towards leeward side. This is a windward side. So at windward side heavy precipitation will be there, and at leeward side there will be the less precipitation. So this is all about the orographic precipitation. So these are the different types of the precipitation. Now we know the precipitation, but how to measure this precipitation or the rainfall? So for which there are the two types of the rain gauges by using which we can measure the precipitation. The first type is non-recording type rain gauge. Actually, in non-recording type rain gauge, Simon's rain gauge can be the one of the example of non-recording rain gauge. Second type is recording rain gauges. So in recording rain gauges, there are the many examples. So what is the basic difference between recording and non-recording? As word from word actually we can have the judgment that something which is a non-recording, and in recording it is the instrument which records. So in case of non-recording actually we have to measure it manually, and that's why it is called as non-recording. Whereas in case of recording actually it plots graph, it gives the intensity automatically, so that or it records something, so that's why it is called as recording. We'll start with the non-recording type rain gauge. Actually the example is Simon's rain gauge. Actually you can see here, so this one is the Simon's rain gauge. Non-recording type rain gauge is most common, and so it is used and it is very simple. So in this non-recording rain gauge, actually I will explain these parts. Like it consists of a cylindrical vessel of 127 mm in diameter. So here you can observe this is a 127 mm diameter, with a base enlarged to 210 mm diameter. And so this is the base, so which has a 210 mm diameter. This is the base, so this is the vessel. cylindrical vessel. At its top section, funnel is provided with circular brass rim, which is 127 mm exactly, so that it can fit into the vessel well. So this is a funnel. Actually, this is the funnel. So it has also has a diameter at top exactly 127 mm. So there won't be any kind of gap, and there won't be any kind of leakage. So whatever the rainfall would be there, it will go through this particular part only directly to the receiver. Okay. So this funnel shank is inserted into the neck of receiving bottle, and which is 75 to 100 mm high from the base section, and thinner plate, actually, and is thinner than the cylinder. So basically it is placed into the into receive rainfall, this particular receiver. So receiver will receive the rainfall, and whatever the rainfall is received, then we can measure, which has a capacity of 100 mm. But many times when the frequency of the rainfall is means if intensity of rainfall is too high, in that case we can increase the frequency of measuring the rainfall. So even in a day it will be drained out, or it will be taken out, and it will measure for 3 to 4 times. Actually, when generally the rainfall is measured, so as per Indian standard time, every morning at 8:30 a.m. We do measure the rainfall, and that would be counted as the rainfall of that particular day. So in this way basically it works. Actually, a proper care, maintenance and inspection of rain gauge, especially during dry weather, is necessary to keep the instrument free from the dust and dirt, so that readings are accurate. So we can have the accuracy of 0.1 mm in case of non-recording Siemens rain gauge. So this is all about the non-recording rain gauge, which is so simple. Second type is recording type rain gauge. The first example is weighing bucket. So in weighing bucket also, if you observe the weighing bucket type rain gauge, it is most common and self-recording rain gauge. It consists of a receiver bucket supported by spring. So this is a uh, collecting bucket or receiving bucket, we can say, and it has a support of the spring. The funnel is provided at top. There is a balance linkage mechanism, and this has a connection with this drum. This is a rotating drum. This is a pin. So when rainfall occurs through this funnel into this collecting bucket, so because of the weight, there would be the movement of the spring, and then this pen will draw on this particular chart, and this chart is attached to this rotating drum. So there are the two movements. One, this drum rotates, at the same time the pen also do the marking as per the weightage. So it has a connection with the time. So with a particular speed, this drum rotates, and at the same time this pen marks based on the how much is the weightage. So directly we get the mass curve by using this weighing bucket type rain gauge. So in this way basically this weighing bucket type rain gauge works. Whereas the next type is tipping bucket. So here you can observe that 30 mm diameter receiver is there. It has connected with the funnel, and then whatever the rainfall occur in this particular tipping bucket type rain gauge, it goes through the bucket. So what there are the two buckets. So one gets filled up, then second opens. So and then another goes down. In the same way, this process repeats. So when another bucket will get filled, then it will go down, and whatever the quantity of the water or the rainfall is there, that will go to the measuring tube. So in this way, basically, these tipping buckets moves or the works, and this tipping bucket has a connection with the electric circuit. And here you can see again in the same way, the way that weighing bucket was working. So this pane is here, this is a rotating drum, and we which has a chart, so that mass curve will be plotted automatically. So in this way tipping bucket works. So these are the tipping buckets. There are the two